Okay, very good morning to all of you. Any doubts from the last class? We were doing the topic of ecological succession, okay? And we had seen, for example, what is primary and what is secondary, you know? We had made a table also. So what is the difference between both of them, primary and secondary? People online also, if you're able to hear and see, just drop a comment. Just to revive, I'll ask you a couple of questions. First question, for example, a very simple question. Which are the first species, let's say, to invade a bare rock? Any example? Lichens and mosses. Lichens are mutualistic, parasitic, predatory, or competition. They are mutualistic. Mutualistic association of what? Algae and fungus. Yeah, this all we've done, yes or no? Okay, algae and fungus. And then after that, no, juglone actually would inhibit the growth. In the specific example of black walnut tree, okay, that example that we had seen. Okay. That was there. We'd also seen the population interactions also. वो भी देखा था हमने. Okay. Other than that, चलो commensalism, amensalism. Very quickly the examples. So what is commensalism? सिर्फ कोड बताना है अपने को. We will talk in code now. And what is benefit? आपने एक केस बता दिया. But second what? What about the other? सबसे पीछे +0. क्या सही कह रहे हैं गलत कह रहे हैं? commensalism. फिर आप इसी what is the example then? ठीक है. Sucker fish remora attaching itself to a shark, right? Example of amensalism. Big tree, small tree. That also we had seen. Okay. Any other example that we can think of? Allelopathy. ठीक है. Allelopathy, is it same to homeopathy or different? What is that? Hello. What is homeopathy? It is a alternative system of medicine. ठीक है. कोई relation नहीं है. ठीक है. Just asking. Allelopathy was what? The secretion of allelochemicals. And what happens when the secretion happens? It can mostly inhibit the growth, but in some cases it can also be a positive case also, when we had seen the example of black walnut tree. Okay, that we had seen. Okay, now what are the 4 functions of an ecosystem? बहुत बार देख चुके हैं हम लोग. अब तो याद होना चाहिए. हाँ. If one, हाँ, nutrient cycling. Second, energy flow. Third, ecological succession. And fourth is homeostasis. ठीक है. Homeostasis आप आगे देखोगे. Homeostasis is ultimately, stasis means static. It means ultimately the ability to regulate your body temperature. Okay. And we'll also see this is actually a very difficult ability to do. Most of the animals and nearly all the plants are not able to regulate their body temperature. Okay. Okay. Let's continue with ecological succession. Okay. People who are watching this is lecture number 5. The other 4 lectures, I hope you've done. If there is any issue, you can also connect and let me know. Now, okay, so we had seen this yesterday. In fact, we had also drawn it with our own hands. ये देखो, we had seen primary succession. Pioneer species, we had bare rock, invaded by lichens. Okay, so plants, shrubs, etc. So there will be intermediate stages, and finally there's a climax community. What are the intermediate stages known as? Sterile stages, yes, series. Okay. This also we had seen. And finally, there's a climax community. Now, how many stages are there after climax community? 0. Why? Climax community is the final stage. Is climax community the most stable stage? It is. Okay. It is the most stable stage. It is the final stage. Okay. Just based on this also concept, we also have certain questions which also we'll have a look at. What is the exact meaning of this? Okay. Okay. Chalo, just a couple of questions so that we get the ball rolling today. If you know the answer, you will raise your hand. People online, for you, this is question number 1. We've done this question so many times. We're doing 2 questions from the PYQs. So one is question number 1, and after that we'll see question number 2. कोई आंसर करना चाहेगा सबसे पीछे आप? हाँ, बैक्टीरिया एंड फंगस, ठीक है. और कोई? सिर्फ 3 सब, only 3 options are remaining now. One is already locked. Second, okay, आप? Second और third हो गए, अब 2 बचे हैं सिर्फ. Only 1 and 2. अच्छा, B, okay. क्वेश्चन नहीं आया. क्वेश्चन की what is the question about? Hmm? What is the first word in the question? सुना है हमने कभी? तो क्वेश्चन सेइंग, अब देखो, they are describing what lichens are, ठीक है? Lichens, lichens जो भी capable of initiating ecological succession even on a bare rock. This you already know, है ना? Are actually a symbiotic association of, बताओ. B, अच्छा. अब आप, for example, and this can happen for some people, it can happen that algae, bacteria, fungus, moss सब same ही तो होते हैं, right? Is everything same or are they different? The answer here is it is a symbiotic association of algae and fungus. It is not a moss. Algae and moss are different. Especially the level of differentiation is going to be different in both of them. Okay. So algae and fungus is the right answer here. Why is the answer not bacteria and fungus? वो तो चलो definition हमने करी है, but let's say why is this not the answer? Because in this case, these bacteria cannot make their food. The algae will be making the food, and it is ultimately a symbiotic association. ठीक है? अभी भी जैसे ही when we start that part of species, and when we do the classification, I'll also go into very basic 1-2 line definition of each. Okay? How is algae and bacteria different, for example? Okay? What are some of the other cases जो हमने देख रखे नाम? Okay? That is one. Another simple question, but slightly tricky in nature. Please see this. This is question number 2. पर सोचना इसमें एक बार अच्छे से. For people online, this is question number 2. कुछ सुना हुआ टॉपिक लग रहा है? यू वांट टू ट्राई आदित्य? जी, अच्छा. अबे, अच्छा, ओके. अच्छा, ओके. Anybody at the back? The question says, well, don't tell me the answer, but tell me, if you just read this, what are they asking you? The topic. Good. Hmm? Right. So basically, they're asking you nothing but pioneer species. बस घूम के पूछा है, right? Which of the following are most likely to be found surviving on a surface without soil. Okay. Now, if I see ferns, ferns will have proper roots, stems, leaves, and they would require soil. उनको soil चाहिए होगा. Ferns cannot be my answer. Okay. I'm left with these two options. Lichens, so I already know. From the very start, in the initial lectures, even yesterday also we saw primary succession and especially the pioneer species will be you start with lichens. So this to has to be in the answer. But if I see both two are there in the answer. Second, even mosses can be there. The answer for us is 3. Take. This is not where we end. This question is tricky. I'll tell you why. The question says can be found on a surface without soil, and there's a mention of mushrooms. Okay. Mushroom is a topic in different forms. Almost every year you'll find a question on mushrooms. The question may not exactly be on mushrooms, but question broadly can also be on fungus. Okay. Now, have you seen any of those images even on the bark of a tree? In some areas, the fungus is present or mushroom is present. देखिए ऐसे images. मुझे बताओ why is mushroom not the answer here? Let's say मैं option change कर दूं. ठीक है तो ठीक है then has anybody seen those images? My point is why is mushroom not the answer? Any idea? We are just seeing the logics and the justifications. The answers will then follow for ourselves. और कुछ? See, देखो, I'll just tell you, this is a slight extra piece of information for you. When the question is saying surviving on a surface without soil, okay, what is soil ultimately providing? Not only is soil providing nutrition, but ultimately soil is having organic matter. Okay. Now, while it is true that mushroom can grow without soil, but even if the mushroom is growing on a bark of a tree, okay, it is still deriving organic matter and nutrition from the bark. That is not true that it does not need any of it and it can barely grow. So if you go by the definition and the sentiment of the question, okay, so lichen can exactly grow even without any nutrition support, etc. It can go on itself because it has the ability to make their food for itself. From that angle, both these two are correct. Lichens and mosses. Okay, so even though mushroom can grow without soil, we're not debating on that. But if the examiner would have meant कि soil का मतलब है would they grow in organic matter or not in organic matter, then that is the correct interpretation. Okay, so there is this one line extra because right now sometimes you also see options like only one, only two. तब क्या करेंगे? ठीक है. So in this question we would have gone with only two. That is a better question. But if the examiner would have made it very clear that surface without soil can also mean that while it is not just soil, can they also grow on bark? तब ये भी सही हो जाएगा. ठीक है? So in this question there is a if for example आप भी सोचोगे सर मुझे कैसे पता होगा ये सारा, तो then it is the job of the examiner to phrase the question that there is no ambiguity. Okay, otherwise that you see in the recent times there have been a couple of questions which either have been dropped, okay, for the simple manner there is no right answer to it sometimes. So now in the recent times, at least in the last 2 years or so, one or two questions precisely because of this issue have had this challenge. Okay, yeah, this is just one extra piece of information. Again, when we do our species and other areas, mushrooms pe, fungus pe, I'll spend some time. How many of you have heard about the term Gucci mushroom? Gucci mushroom. Gucci mushroom is very cheap or very expensive? Very expensive. Okay, that is why all the celebrities, okay, including the Honorable Prime Minister, okay, there were articles how they eat Gucci mushroom. Okay, कहीं पे लिखना just read about it. What is so special about Gucci mushroom and where is it found in India? This has been asked by UPSC in prelims also. ठीक है, चलो let's come back. So we had seen this. Okay, this is primary and this is secondary succession. Secondary में what is the difference? You already have vegetation available. Let's say there was a fire. This could have been man-made, this could also have been natural. Now, main thing is the soil, etc., still remains. And then the succession starts. So this is nothing but secondary succession. We've already made a table, etc. Now, we had also done in the last class the classification of succession. And the classification was based on, Pehla classification is based on vegetation. If you don't have any vegetation, it is primary. If you have it, secondary. Okay, so this is secondary. I had vegetation to begin with, but because of some calamity, because of some man-made interference, there was some issue, and then later on everything started to happen. That is secondary succession. Fine. Then we had written based on the initiating agent. Here, ये लिखा है हमने. Second is autogenic and allogenic, right? So we are writing the types of succession. So based on vegetation we have done. Now we are doing it based on initiating agent, and from the name this is very easy to understand. One we are saying is autogenic succession, and one we are seeing is allogenic succession. देखो, auto means by self. Simple चीज है, if the succession is started by the organisms themselves in that area. Okay, that is known as autogenic. Then what would have been allogenic? It is started or it is done by outside factors but not by the organisms. That is allogenic. Iski one line definition will also write. Okay, any of the outside factors, let's say, basically meaning not done by the organisms themselves. That is allogenic succession. Okay, this was one. And third one, what one we had also seen was based on water. तो यहाँ पे three terms आते हैं. One is hydrarch, is there arc. Okay, अब देखो, in later on also if you see terms like xerarch, anything with xer, zero coals, etc., please remember this is only related to desert, yeah, desert like dry conditions. Okay, the madhyam mark, the golden mean here is mezarch, that is between. Okay, so this we have seen based on the initiating agents. Okay, so we'll write for autogenic a simple सी definition. What is autogenic, and then we'll see that. So autogenic पे succession driven by organisms, the bracket में biotic community themselves, organisms, biotic community themselves, okay. इसका you can write a very simple example here, right? Lichens leading to mosses, leading to में you'll make this sign, and वहां से grass. जैसे for example, a very simple example can be this is a simple succession. Succession driven by the organisms, that is the biotic community themselves. Okay, so lichens, say mosses, say grass, right? In allogenic, we'll write succession caused by external environment factors. Succession caused by external environment factors and not by the organisms themselves. Okay. Now, in the first part, we had written biotic. ये था ना, this is by the organisms or the biotic community. Here we'll write this is driven by the abiotic factors. So you can write abiotic factors like climate, fire, floods, landslides, or even human activities cause it. Or even human activities cause it. So for example, if we were to say, जैसे यहाँ पे allogenic succession है. So let's say there's going to be flood in some area. Okay. Flood can create a marshy kind of a land. Okay. तो यहाँ पे जैसे example आप ऐसे बना सकते हो, floods will lead to a marshland. Now flood was this abiotic, it was external. This has led to the succession. तो difference किसमें, biotic में है और abiotic में है. Within the initiating agent, there is also one, but वो नाम से इतना आसान है, so I'm not making you write. But if you want to, you can just write. In the initiating agent, you can also write one is autotrophic versus heterotrophic succession. This is also based on the initiating agent, but directly from, because you already know what these terms mean. देखो, autotrophic means यहाँ पे in these areas you will have domination of plants. Okay, plants will create the food, right? They will be eaten up by, in that area only deer succession can start properly. Heterotrophic means in this area you don't have enough plants. You will have heterotrophs. A simple example can be, let's say there's a deer, there is a rabbit, right? They can take some seeds, they can drop these seeds in some other area. So succession is started by heterotrophs and not autotrophs. And then later on the plants etc. can grow. So just from the name you can make this out. What is the meaning? Autotroph mein, it is the plants are dominating and they are driving the succession in that area. In heterotrophs, the succession is driven by the heterotrophs. Okay, the ones who eat. So maybe they'll go to some other area. They may take certain pollens or seeds with themselves, deposit in other area, and then the succession would start. Okay. The main cheese from the name only you can make it out. So initiating में, normally in your books you will find autogenic and allogenic. Because allogenic from the name you cannot directly guess what are the meaning. Allogenic में driven by outside external or the abiotic factors. Here it is driven by the biotic factors. Whereas in autotrophic it is driven by autotrophs, like the plants in that area themselves. Whereas heterotrophic में क्या होगा? By the heterotrophs. Heterotrophs are generally those who eat plants. So there can be some areas जहाँ पे this can happen. Yes or no? Which is again why pollination and all these activities are very much integrated. It is not always that plants ही हर जगह dominate करेंगे. There can be some regions, let's say जहाँ पे ज़्यादा overgrazing हो गई हो. Yes or no? So then in those areas, how the succession would happen? Again through heterotrophs. Okay. So when you've written this, एक कहीं पे बस just write this autotrophic versus heterotrophic succession. This is also another type that is mentioned, so that just to remember from the names only. And from the, this is again self-explanatory almost. The meaning of this autotrophic and heterotrophic. Okay. Then the last part is this water related, which is your hydrarch, mesarch, and xerarch. Okay. Now here the main thing is the succession which happens when you have abundant water is your hydrarch main cheese hai. When the water is abundant. Xerarch is simply when you have limited, very limited water, very dry conditions. ठीक है. Tomorrow also we'll see, or let's say in the next class, that how, especially in desert or dry like conditions, how organisms would evolve themselves. जैसे we had seen the example of cactus, हमने बात करी थी. Okay, that cactus does not have leaves. Cactus would have thorns mostly instead of leaves. That is their way of controlling the evapotranspiration losses. Okay, and mesarc here is in between, wherein it has a moderate amount of water and the succession happens because of the moderate amount of water. So this, from the name also, you'll get to understand what the three terms exactly mean one by one. Okay, all the three terms in this case, exactly, right? Okay, so isme, even this is more than enough for you to know. I'll also then go to a couple of points also, I'll tell you. Just say this is something you shouldn't remember. Pioneer community, we've seen what is this? Lichens and mosses. Climax community is forest. Yesterday also we had seen this. So visually also you get to know pioneer community, and ultimately the pioneer species are the ones which are first to invade any area. Okay, and climax community like forest, these are the most stable communities. Okay, now if this you've understood, the last two headings we have to write. One is write the stages of, now this we'll see slightly more detail. There are some more stages. Like stages of ecological succession, and last we'll see is significance of ecological succession. Now, stages, in the last class, we at least know there will be a starting stage, which you have domination of pioneer species. In between, you'll have a lot of intermediate stage, and last, you'll have a climax stage. Okay, and for every stage, we'll write at least one line each. Okay, so you can write the very first stage is nudation. And with nudation, think of a nude or a bare rock. Till now, they've not asked you the exact sequence, but perhaps if they want to ask you, this is the sequence: nudation, invasion, echesis, competition, reaction, and stabilization. One by one, for each process, we'll just write one line each. Okay? सबसे पहला process है nudation का, you can put a dash and write. This is the initial stage. This is the initial stage where a bare, this is B-A-R-E, bare slash disturbed area, where a bare slash disturbed area is created due to natural or human activities. Natural or human activities. This is nudation. Second is invasion. Second is invasion. This we have seen, right? This nude or a bare rock will be invaded by lichens, mosses, etc. So invasion may you can write the process where pioneer species begin to arrive in the area. The process where pioneer species begin to arrive in the area. Full stop, right? They disperse. They disperse. They disperse spores slash seeds to establish themselves. Spores seeds to establish themselves. Next is echesis. थ्री थ्री, हाँ। इकैसिस एक और आसान वर्ड है, ब्रैकेट में लिख लीजिए इसको, एस्टैब्लिशमेंट। इकैसिस इज एस्टैब्लिशमेंट। Right, the stage where pioneer species, gases is the stage where pioneer species successfully germinate. Pioneer species successfully germinate, comma, grow, and establish themselves. Establish, sorry, they successfully germinate, grow, and establish themselves, starting the formation of a new community. Starting the formation of a new community. Next stage is aggregation. Aggregation. Right? The stage where aggregation is the stage where more individuals, of the same and new species join the community. More individuals of the same and the new species, they join the community, increasing the population diversity. Aggregation means more people are coming in. For example, apps like Ola and Uber, they are known as cab aggregators, right? What they will do, they will bring everybody together. So what has happened till now? There is a simple bare rock invaded by species. Ecasis is when they start to propagate, which means they start to establish. कैसे करेंगे establish? Through spores or seeds, okay? And there is aggregation. So now new species will come and join the area, okay? And then of course जब species बढ़ेंगी तब शुरू होगा competition. Competition is not there when there is nobody in the ground, yeah, let's say, right? Competition is only when the species start to multiply, they come more in number. So four stages क्या है? Nudation, simple bare rock मानो. It is invaded by the pioneer species. Ecasis is how the pioneer species start to establish themselves. Aggregation is when more and more start to come in that area, right? Then it is followed by, right, competition. Fifth step is competition and co-action. Competition and co-action. So here it is simple, right? As the communities grow, they compete for, as the communities grow, they compete for similar limited resources. They compete for the similar limited resources like light, nutrients, space, etc. Okay, so this is where competition would start. Next is reaction. Reaction. Right, the communities modify the environment. The communities modify the environment by changes in the soil. Modify the environment by changes in the soil and nutrient cycling. This is also a topic we'll do, nutrient cycling. And the last is something that we have seen so far is stabilization or climax. Stabilization or climax. Right, this is the final. Final means this is the boss stage. This is the final. and most stable stage of this ecosystem. Final and the most stable stage of the ecosystem, which supports diverse and a resilient community. Which supports a diverse and a resilient community. Okay. And last for us is significance of ecological succession. What do you think would be the significance of succession? For an ecological angle, you've seen the stages, you've seen the basic understanding. What is the significance of it? ठीक है और कुछ सही है point? Think about soil and biodiversity. So in succession, does the biodiversity increase or decrease? It increases. And you also have a stable community. Okay. If I'm saying if a community at the last is stable, okay, I want to ask you, would it be diverse or would it not be diverse? सोचो अगर community last में बहुत stable है, the stability of the community, and this question you will get the answer in just the topic after this, जिसमें हम food chain और food web की बात करेंगे. Hmm? I'm just asking you, सोचो. I'm asking you, if I say a community is very stable, would that community have high biodiversity or low biodiversity? और both दोनों सही हो सकते हैं. And somebody can also say, sir, nota, none of the above, or I don't want to answer this. This is the invasion of my right to privacy. हाँ, चलो, ठीक है. I'm just putting a thought in your mind. ठीक है? I can directly tell you, but then that will take away the joy of explaining it and creating the concept. The question that I've asked you is number one, and in fact, I'll ask you two things related. If I say a community is very stable, which is normally a climax community, this is the most stable community. Two things we have to see: whether or how much biodiversity, whether would it be low or high? One thing, okay. Second, think about, is it resilient to disease? Is it not resilient to disease? Another question we can talk about. Third question is related to its productivity. And more than productivity, I want to know variation in productivity. In your case, I'll take a very simple example. You know what is the difference between production and productivity? Hmm? Just for example, I take two examples, let's say, right? I talk about, let's say, Lamborghini. Okay, I take some other car. कोई और अपने मन की कार बताओ. Suzuki. चलो ठीक है बहुत. So let's say there's Maruti and there's Lamborghini. Fine. Both, and I give you a number, 100 cars are produced. Both of them produce 100 cars. Production is same. Productivity will be in how much time? Let's say Maruti produces 100 cars in 1 hour. Lamborghini takes 1 month to do it. Which has better productivity? बताओ. Maruti. Production per unit time is productivity. Very simple. Now take your example. If you are studying very, let's say if somebody says that you are a very sincere student, you are a very consistent student, would you have huge fluctuation in your productivity, or you will study almost the same almost every day? Fluctuations कम होंगे. Yes, it means if you're studying almost 9 to 10 hours a day, किसी दिन 8 होगा, किसी दिन 9, किसी दिन 10, but range of fluctuation is very small. That means you are very consistent. That means you are very stable. Something that is not stable, would that have high variations and fluctuations? Yes or no? So that is correct. At least on this part, you are thinking correctly with respect to productivity. Fine. Now come to diseases. This community that is very stable, would it have many diseases or it would have very less diseases? Less is correct, right? And main thing is it will have high resilience. Itni, let's say for example somebody says, sir, I have very high immunity. What would normally happen? Even if the temperature changes, weather changes, you are not easily affected, you have good resilience. And even when you are let's say impacted, maybe in 1 or 2 days you are back to normal. Fine. That also tells me stable. Third aata hai sabse important, biodiversity, and here you have to imagine whether this would be low or high. Okay, socho. Ab dekho, I'm saying something is stable. Fine. So for example, I'll take another example, not of environment, and then I'll come back to environment. Okay. Let's say there's Tata Group. Tata Group has huge diversity of companies in its portfolio, and we say the revenues, the shares of Tata Group are very stable. Now, even if 1 or 2 companies does not work well, if they tank, if they collapse, the shares and the profits of Tata's would not be impacted. Why? They have a huge diversity of portfolio. Is this correct? Versus a company which barely has, let's say, 1 or 2 subsidiaries. Even if one of them collapses, or even if half of that collapses, will everything get impacted? Yes. Now, in nature, if there is a unstable community में बहुत कम biodiversity होगी. The biodiversity will be very less, which means if any of the species gets impacted, the entire ecosystem may collapse. So low biodiversity is also related to low stability. Because at the end of the day, let's say this is a cat. There are two options with cat. Let's say in this, cat can eat 1, 2, 3, 4. Another example is cat can only eat 1 and 2. What if 1 or 2 collapses? In this, there's a higher chance of cat not getting food. Here, cat has 4 options. Even if 1 is taken away, still has 3 options. Even if 2 is taken away, it has still options. So please understand, if I say a community is stable, it means it is very high amounts of biodiversity. That even if a couple of species are lost, even they get extinct, still the community will be able to perform really well. And this is how biodiversity has evolved. So when we move from the bare rock to multiple stages in between, and finally when you have the most advanced forests, there is a huge biodiversity that has brought in, which is why, for example, Amazon rainforests, they have huge amounts of biodiversity. वहाँ पे इतने तरह के plants हैं, many of these plants scientists have not even fully understood them. Right? You would have seen movies on anaconda and etc. in the Amazon and some of these forests. Why? And sometimes most of the anti-cancer drugs we found in these are found in these regions because they have a lot of potential that is yet to be explored. So three things you have to understand. If I say any community is stable or very much stable, it will have high biodiversity, right? And this has evolved over a period of time. Second, the diseases or the disease resilience is high, which means if the disease resilience is high, diseases are low. Third is productivity. Productivity would also be high, but the variation in the productivity will be low. Variation is low, which simply tells you it is going to be stable in nature. Are we clear on the three concepts? Okay. So first write down significance. Last में ये 3 points भी हम लिखेंगे. Significance of ecological succession you can write. Number 1 is soil formation. One is soil formation. Simple है. Bracket में you can write lichens and mosses. They help in doing this. Second, biodiversity enhancement. You can write an example. देखो a pond undergoing succession. A pond undergoing succession develops into a wetland. Wetland is an ecotone, right? Develops into a wetland. Supports fishes. Supports fishes. Birds. etc. How many Ramsar sites are in India right now? अभी तक 91 है, ठीक है. Maybe when we start the topic, I hope it remains the same. Otherwise, 2-3 और याद करनी पड़ जाएंगी. Okay. नहीं नहीं नहीं, कैसे करनी है और क्या करनी है वो that we'll see. And they have never asked you in this manner. Only some of the most prominent ones. There was one question when you have to match. Okay, so I think 4 sites they had given here, their locations, and you have to match which is correct. Third is ecosystem stability. Ecosystem stability. Right? A climax community. A climax community is more stable and resilient to disturbances. A climax community is more stable and resilient to disturbances due to its underlying complex structure. Due to its complex structure. So in a climax community, ultimately, see, अगर structure बहुत simple है, let's say this is animal number 1, it has only 2 options to eat, A and B. This is very simple. Anything happens, this may collapse. What is complicated? Animal number 1 is having many options, and each options will have their own options. So slowly and steadily, when life has evolved, organisms have also adapted. So you want more and more complexity. जितनी complexity होगी तो इतनी आसानी से चीजें टूटेंगी नहीं. This is again the understanding of food chain and food web. If there's a very simple food chain, सबसे बड़ी problem क्या है food chain में? Let's say species A eats B, B eats C, C eats D. What is the biggest problem from a nature's perspective? अगर C या B या किसी को भी, if anything happens, then entire chain gets lost. Chain में this is the problem, which means if you're only dependent on the other species, you have no other options, this will collapse. Whereas same चीज है, जैसे A है, B, C, D. However, here each of them have other options as well. For example, right, some here back and forth, etc. Which has more chances of survival? Batao. Second one. And this is what happens in nature, right? Why many species survive? One, of course, they have more options. Second, they adapt in very difficult conditions. In very cold conditions, for example, the bear will go for hibernation for 6 months. This is a way of saving itself. अगर खाना नहीं भी है, so what they'll do, at least for some times, they may starve and they will reduce the metabolic rate. Right? For example, the same thing that we do in fasting. Okay, so we'll see all of this, right? So we had written a climax community is more stable and resilient to disturbances due to its complex nature. Complex important hai. Another point you can write इसी में, a mature forest, because in this topic you'll get applied kind of questions. A mature forest with diverse plants and animal species, can recover more easily from small scale disruptions. Okay, one more point you can write. Succession, fourth point, succession allows damaged ecosystems. Succession allows damaged ecosystems to regenerate naturally, allows them to regenerate naturally, and reduce the need for human intervention. ठीक है? Now, what we had discussed here, just for your understanding, you can also draw this with me. For example, if a community is unstable, it has low biodiversity, okay, it has low resilience to diseases, and it has low ecological productivity. Whereas if a community is stable, the moment we say stable, your mind should tell you we are talking of climax, which means the final stage. It has already undergone a huge, let's say, time. So a stable community will have high biodiversity and also high resilience to diseases. We're not saying it is immune 100%, but resilience is high. And precisely because of this, it will have high ecological productivity. Productivity will be very high. In bracket, you can also write down low, it will have low variations in productivity. Anybody who is stable will have very low variations. If I say a company's profits are stable, so almost every year they'll hit a certain amount. It would not be that one year 100 crores, other year 1 crore. That is huge variation. So here they will have low variations in productivity. यहाँ पे ज़्यादा हो सकते हैं. It may happen they are doing good, but all of a sudden there's a disease and they collapse. तो लो में इशू क्या है? हाई वेरिएशंस है, एंड हाई वेरिएशंस आर नेवर गुड इन प्रोडक्टिविटी. हाई वेरिएशंस को आप ऐसे समझो, दीज काइंड ऑफ ग्राफ्स. हियर इट इज ऑलमोस्ट लाइक अ स्ट्रेट लाइन विद वेरी minimal variations, right? So out of the 4 functions of an ecosystem, one we've done. One is ecological succession. Second, now we'll do is energy flow. Okay, how energy flows. Now this also is going to borrow from some of the topics that we have done, right? So we are now, right? Before I start, if I were to just summarize everything that we've done in 1 minute for the previous topic, the topic heading was ecological succession. So first you need to know what is succession. So basically how the communities evolve over a period of time, number one, right? Second thing is you need to know what are the basic, some of the terms and stages. You have pioneer stage, you have intermediate stage, and you have final stage, that is climax community, right? Pioneer stage के examples are mosses and lichens. Intermediate stage are known as seral stages. The climax community in general will have high biodiversity, will have high productivity, low variations, high biodiversity, etc. And of course, high resilience to diseases. Fine. Then, what are the types of succession? Based on vegetation, there will be 2 types. What are they? Primary and secondary. Primary में vegetation was there या नहीं था? Nothing existed. Everything starts with a scratch. Secondary में the vegetation was already there, but because of some challenges, it got lost. Which is faster? Secondary. Which is slower? Primary. Second is based on initiating agent. So one agent can be autogenic and allogenic. Autogenic is biotic factors. Allogenic is external factors which can be abiotic factors. You can also have autotrophic and heterotrophic succession. Yes. Autotrophic brought about by plants. Heterotrophic brought about by the heterotrophs. And of course, you can also have Hydrarch, Xerarch, Merarch. This is basically based on water availability. नाम से clear है? Then you have stages of ecological succession, and we've seen 7 stages. We start with nudation, invasion, third, ecasis is establishment, fourth is aggregation, fifth is competition, coaction, sixth is reaction, and last one is climate community. And then we had seen the significance of ecological succession, right from soil to stability to biodiversity, okay, habitat creation, all of that, right, restoration of some damaged ecosystem. All these are examples of the significance of ecological succession. Okay, is that clear? Right? अब बताओ, बहुत simple topic है. But UPSC will ask you in the manner, let's say, which of the species are to be found in an area even without soil. They're asking you exactly what? Primary succession. Okay? Second function is energy flow. Okay? Now here we will go back. Okay? So we'll understand what energy flow is. Okay? So we will see, for example, here food chain. Okay? A food chain we'll see in terrestrial also, and also we'll see in aquatic ecosystems. Then we'll also see concepts like food web. In energy flow, we'll also see the different pyramids. The pyramids can be of number, biomass, energy. Okay. We will also see, okay, some laws governing it. For example, there's a very famous 10% law related to this. We will also see a concept known as ecological productivity. We have just mentioned it, but energy flow जब आप पढ़ोगे, this will be more clearer. Okay, and अच्छा, pyramids में भी हम उनकी limitations भी देखेंगे. Not everything is perfect with the pyramids. What are the issues, etc. This is what we will see. Okay, very important topic, very important for understanding the environment and how things happen. Right? Energy flow hai, food chain, food web, pyramids, 10% law, and ecological productivity. This is all we'll see abhi. Right? Now, there's a term that is mentioned is food chain. Now, see, देखो, energy flow हो रही है. Couple of things you need to know. Is the flow of energy, okay, if this is clear to you, चलो मैं यहाँ पे लिख देता हूँ so that कुछ क्वेश्चंस आपके क्लियर हो जाएं. Now, the very first question is, flow of energy, right? Who creates food? Hmm? चलो, who creates food? Plants. ठीक है? How do the plant create food? Photosynthesis. What is important in photosynthesis? Sunlight. So basically, you have energy from the sun. Plants, in the presence of sunlight, okay, plants are eaten up by, let's say, and let's say this is eaten up by a lion. Now, can you tell me, this flow of energy, is this unidirectional? Is it bidirectional? Is it multidirectional? एनर्जी फ्लो किस तरह से हो रही है? प्लांट से अगर रैबिट में जा रही है, and from rabbit if it is going to the lion, the flow of energy, is it unidirectional, multidirectional? How is it multi? For example, देखो, plant से it is going to deer. Is the energy going from deer to plants वापस? It is not. Similarly, when the deer is eaten by a lion, is the same energy going to the plant? Not really. So please remember, if 100 units are produced by plant, some units will go to, let's say, a rabbit, and only a very limited unit will go to a lion. Okay, the flow of energy, अभी के लिए बस ये याद रखो, flow of energy is एक तो directional and main is it is going in one direction from the creator, that is the plants, to the next level, to the next level. The moment I'm saying levels, in this whole topic we will see the organization in certain trophic levels. This is the term we will see now, trophic levels, जैसे, right? So for example, if this is, we've already done population dynamics, याद है? उसमें pyramids बनाते हैं. You have a young population, okay, middle population, old population. Here, for example, I've given a big space to plants. Why? Because let's say they are more in number. This is one trophic level. This is supporting another trophic level, which is supporting another trophic level and another trophic level. This is tapering. Why? Because the numbers are decreasing. That is why this is tapering. Numbers decrease हो रहे हैं. The numbers are decreasing as I move upwards. Okay. First, abhi the term that we have seen is trophic levels. Okay. So trophic levels are signifying the space an organism occupies. And this is just a visual depiction, nothing more than this. Just for easier understanding, we have divided animals at various levels, because for example, plants will be eaten up by a certain organism. This is eaten up, and let's say there's a apex, yet top predator. Right? A very simple understanding we get from this. The main thing is energy flow. Right? Energy, without flow of energy, nothing can survive in the ecosystem. That is also true. Yes or no? Now, I'll show you some visual depiction that will make sense, and we will see it for both. Many people are aware about terrestrial, how energy flows in a land. It is very easy. Yes or no? You will have plants. Plants will be eaten up, so there's a simple food chain. But it gets complicated when it comes to aquatic. In the very first lecture, we had seen who produces food in aquatic ecosystem. Hmm? Achha, but a better example is phytoplanktons. Okay, we'll see all of this now. Okay, I'll show you some specific cases also one by one. ठीक है, चलो यहाँ से शुरू करते हैं. Just you have to see some of the diagrams here. Now this is normally a food chain. Fine. Food chain can be 3, 4 and 5, but not more than this. The reason is, as you move and as the organisms change, there's a lot of energy that is lost in every process. Okay, देखो, जैसे corn eaten by rat, eaten by a owl. Carrot, rabbit, fox, etc. ये grass, grasshopper, frog, python, eagle. One thing you have to remember, that energy is lost, I should say energy is consumed in every stage. Okay. Now maximum energy is consumed in a process that is known as basic दो process हैं. In respiration and metabolism, maximum energy is consumed in this. That is why you don't have more than 4 or 5 trophic levels. क्योंकि let's say यहाँ पे मान लो energy, this is around 10,000. Only 10% energy is transferred. I had written 10% law. According to 10% law, only 10% energy is transformed from one level to the other. Save 10%. We are not saying 10% energy is lost. We are saying only 10% of the energy is transferred from one level to the other. It means कितनी consume हो रही है? 90%. So 90% is either consumed or at least dissipated or lost. Right? Where is this 90% getting consumed? Respiration and metabolism. Right? So, which is why if 10% energy is transmitted, 10% इसका भी 10% यहाँ जाएगा. In this case 10% comes here, 10%, 10%. So from lion, there's hardly any energy remaining that can be transferred to the next level, which is why you do not see trophic levels beyond 4 or 5. Main thing is you don't have enough energy available. And this is exactly how nature has made it to be, right? Which is why you have a lot of plants. Plants will be in lakhs, others will be in, let's say, thousands, something will be in hundreds, something will be lesser. That is why every species will have its own function, and everything is determined by the energy flow. अब नेचर में ऑफ कोर्स फूड चेन ऐसे नहीं होती है. दिस इज ओनली फॉर आवर अंडरस्टैंडिंग, फॉर आवर सिंप्लिसिटी. इट इज एक्चुअली अ फूड वेब एंड थिंग्स आर वेरी कॉम्प्लिकेटेड. ओके, जैसे कि चलो एक ये भी, दिस इज अगेन अ सिंपल फूड चेन दैट यू आर सीइंग, बट in nature you have things that are more complicated, right? जैसे something like this, something will have various other options. Yes or no? Because in the issue of food chain is, जैसे यहाँ पे भी grass है, if it was purely a food chain, what if rabbit is removed, everything will collapse. But in reality there are so many other nodes that are connected. The food chain is only for simplistic way of understanding. Yes or no? Exactly, this does not occur in the nature, but for our reference it is a good point to understand. Fine. So again, going back, you have a simple food chain, right? This is easy to understand in the case of terrestrial. Terrestrial means land-based systems. Now, when we see this for aquatic ecosystems, aquatic में you have a basic example जैसे कि in aquatic ecosystem, of course, you have phytoplanktons. They are eaten up by zooplanktons. Zooplanktons eaten up by, simple example, small fish. You have large fish. Okay. Now we'll see a name of certain phytoplanktons. Okay. Any name that you remember? What is cyanobacteria? Diatoms. Dinoflagellates. Cyanobacteria. Diatoms. Dinoflagellates. Copepods. Foraminifera. Zooflagellates. People online, you can also keep writing this. Copepods, foraminifera, radiolarians, zooflagellates. एक और एग्जांपल लिख सकते हो यहाँ पे. Coccolithophores. ठीक है? And with the coming classes and some, I will give you some reference points to at least remember some of them. There will be some uniqueness found in at least this. So it will not be very boring कि यार इतने tough नाम हमें याद करने पड़ रहे हैं, right? Now, you have to read some things. I'll tell you in the respective portions. There is a specific topic on aquatic ecosystem. एक लिखो, the great oxygenation event. Read about it. This is with respect to cyanobacteria. The great oxygenation event. And the reference I'll tell you, because when life started, we know there's a huge carbon dioxide that was present everywhere. So what made life possible is oxygen. In that, cyanobacteria played a very important role in making life possible. That is known as the great oxygenation event. तो इसमें अपने को क्या देखना है, the role of cyanobacteria, how they started and how ultimately more and more oxygen. Of course, we know all these are basically phytoplanktons. क्या है? देखो, दो terms है. One is phyto. Whenever you see the term phyto means plants. Photo is light. आपने सुना photosynthesis. Photo is light. Phyto is plants. Okay? And planktons are your marine microscopic organisms. Out of them, of course, one is phytoplanktons. They produce the food. If they produce the food, they'll do exactly what the plants do. They will also need sunlight. Okay? I want to ask you, these are phytoplanktons, for example. Let's say this is the ocean. This is the top layer of the ocean. This is sunlight. This is the bottom of the ocean. If we were to place phytoplanktons, assuming all these things, where would you place phytoplanktons? Top pe, middle pe, bottom pe? बताओ, bottom पे, right? Why? Okay, और कोई? Why top? Main thing is sunlight. I want them to be as close to the sunlight, because slowly and steadily the sunlight cannot percolate deep inside. Deep inside it is going to be very dark. Yes or no? So यहाँ पे you'll get different type of organisms which don't need to do photosynthesis, and that is also very interesting to know. For example, nearly around 80 meters or so in the top regions, you will have your plants, which basically means your major phytoplanktons. And they have to do what? Photosynthesis. That is why they are very close to sunlight. Right? But in the depths of the oceans, right? Depths में अपने को मिलते हैं benthic organisms. Right? They can survive, but they don't need sunlight. There must be some special mechanism. So you've read till now about photosynthesis. There is another thing that is known as chemosynthesis, wherein you don't need light. There is a disintegration of chemicals, and from that only the nutrition is provided. Of course, chemosynthesis would happen in the deeper regions where light is not possible. So normally everybody knows about a photosynthesis. Chemosynthesis हम कल देखेंगे when I do with you the sulfur cycle. Then I'll again tell you. This is, we'll do this in nutrient cycling. Okay. Okay. Just to give you a reference. Now, tell me the names of phytoplanktons जो हमने देखे. Cyanobacteria. दूसरा. Diatoms. तीसरा. Dinoflagellates. Even if you say dinosaurs, it is okay. Dino तो बोल रहे हो, right? So one is dinoflagellates and last is coccolithophores. Okay. One homework I had given you was great oxygenation event. Now something happened last year, was there across almost all newspapers. Just write down stromatolites. ये लिंक भी हम आगे जाके बनाएंगे. अभी के लिए you just have to write stromatolites. In India, they were also found outside, and it is linked to what we have just mentioned. अभी के लिए बस ये देखो, these are made up of cyanobacteria, right? And this was in the news. If you just see this in news, you'll see so many articles on them in the recent times. अब देखो, make article है अभी, 600-year-old stromatolites in the Himalayas tell the story of an ocean. They have been now in the recent news. Stromatolites in pulsed oxygenation. Okay? फिर से देखो जून का आर्टिकल. World's oldest stromatolite fossils in found. So this is a part of your current. Okay, I'll talk to you when I again do you Himachal mein, even in other parts or not just in India. Stromatolites are in news. This is how the examiner can link your static as well as current. For example, you just are aware about cyanobacteria. अभी तो मैंने सिर्फ नाम बताया आपको. I've linked it only to a great oxygenation event. अब यहाँ पे क्या है? This is where geology meets environment. रॉक फॉर्मेशन है, उसमें कहाँ पे मिल रहा है, मेन चीज है ये क्या है. अगली बार अगर सवाल आएगा, फॉर एग्जाम्पल दे विल जस्ट आस्क यू स्टोमेटोलाइट्स, बट दैट सवाल विल बी लिंक्ड टू साइनोबैक्टीरिया. फाइन. एंड अभी आई हैव नॉट टॉट यू दिस टॉपिक येट. So whenever we do topics, I'll give you some nearby updates, and when I do them, then this will become very easy for you. ठीक है? So maybe any one article, whenever you find time, read it. I will be covering it in the respective portion where I want to cover this. ठीक है? तो ऐसे काफी आर्टिकल्स हैं. अदरवाइज अगर आप इसको रैंडमली देखोगे ना स्टोमेटोलाइट्स, यू विल नॉट बी एबल टू कनेक्ट इट. वी आर पुटिंग एवरीथिंग इन इट्स प्लेस. Okay, so two things I've asked you to do for cyanobacteria. One is the great oxygenation event, even that is linked to stromatolites, by the way. And second is stromatolites. If stromatolites, you will write it. Any specific article you want to read, if you want to read Indian Express article, just go through it very simply. Okay, but इसका जो take away है, I'll do that in the respective coming classes. Is this term clear? Stromatolites. Okay, I hope people online have been able to follow. ठीक है. Okay, so we have seen 4 names till now. You have cyanobacteria, you have diatoms. Okay, then you have dinoflagellates, and you also have, ठीक है. Okay, for dinoflagellates, you already know one very good example for dinoflagellates. I'll give you in fact 2 examples, तो आपको ये याद रहेगा. Dinoflagellates. ठीक है. First example I'll tell you is your zooxanthellae. सुना है? Zooxanthellae is found in which zoo of India? बताओ. 2 ऑप्शन दूंगा आपको. दिल्ली जू या गुजरात जू. आप कहो सर मैं तो गुजरात से हूँ, डेफिनेटली गुजरात जू. आप ट्राई करो. अब है विद जू, दिल्ली या गुजरात. जू में नहीं है, चलो ठीक है. Zooxanthellae are your algae which are associated with coral reefs. Yes or no? Zooxanthellae is nothing but a dinoflagellate. A more technical name is dinoflagellate. One example is zooxanthellae. Right? Next example which I'll tell you, most of you would have seen it, and it's a very interesting example. Okay? What we are talking about, name can be slightly complicated if you're seeing it for the first time, but as an example, it stands out. Noctiluca scintillans. बड़ा complicated नाम लग रहा होगा. Yes? But when you see it, you will think अरे तो बहुत अच्छी चीज है. Now, how many of you have seen the images of the beach glowing in the night? ऐसी कोई इमेज देखी आज तक? अच्छा, कहाँ पे देखी है? अच्छा, ओके. ये देखो, दिस इज ग्लोइंग. Can you see this? This is why is it glowing? It is glowing because of Noctiluca scintillans. This can be seen in the Juhu beach, sometimes in the beaches of in the Pondicherry, many other regions, and of course globally also. Let's say implications for India of Noctiluca scintillans, maritime domain, etc., etc. It is a large. तो क्या लिखा है? Noctiluca is a large dinoflagellate. It is a phytoplankton. अगर अब आपको ये नहीं है, if you don't have the reference of information, आप कैसे याद करोगे? आप बताओ. Yes or no? So Noctiluca, in this case, please remember, helps the glow of the oceans. Right? This is one example. Again, your homework is what makes it glow? ऐसा क्या special है इसमें? Is there anything that can glow in the word? एक तो ये example है glow का. Any other example? जुगनू, ठीक है? जुगनू सुना है हमने? Badsha also has a very famous song, Jugnu. Okay. Similarly, for example, I can give you fireflies. They also glow. Your homework is how are they able to glow? You will see it from an environment and a science perspective. What is any, of course, they will have an enzyme in their body. What is that enzyme that makes it glow? In the recent years, sometimes species adaptations and behaviors, new tough questions are getting asked. Right? My question to you is I've already told you it glows. But my question to you is why, yeah, how it glows. ठीक? Can mushrooms glow? कर सकते हैं. All this thing जो glow हम कह रहे हैं, that phenomena is known as bioluminescence. Okay? Bioluminescence can be seen in waters. Yes. Can it be seen on land? Yes. Example, insects जैसे कि fireflies can show this. It can also be displayed by mushrooms. So the homework that I've given you, right? If they're glowing, my question is how are they able to glow? What is that name of the enzyme, if that be the case? So for the examples, if you have some reference points in your head, अब आप नहीं बोलोगे dinoflagellate को. At least either zooxanthellae you'll remember, or you'll remember Noctiluca scintillans. Yes? Noctiluca, you will at least remember there's a beach. The beaches, the waters of the beaches will glow. It's a very good visual spectacle. The tourists will also come and see this. Right? Okay. Coming back. Okay, we were here. So some examples we've seen abhi. Slowly steady, I'll introduce you to other terms also. When I do aquatic ecosystem. Are we clear on what is a food chain? Terrestrial में पता है अपने को. And this is for aquatic. Next. And again, if time permits, you go through these also. Any special thing that you get to know, I'll cover this more in more detail in aquatic ecosystems. Okay, the other remaining ones. Now, can you see an algae? Ultimately, a plankton. There's a krill. Okay. There's an Arctic cod. Cod सुना है आपने? Fish. Have you heard about cod liver oil? Right. That is nothing but this fish oil. Leopard seal and ultimately a polar bear. Simple. This is also an example of how the energy is flowing from one to the other. Right? And this is exactly what you're seeing in the case of the ecosystems, right? Now, when you see the polar bear, any reason why a polar bear is very bulky, has a lot of fur, right? Because it is very cold in the polar regions. So the polar bear has to keep itself warm. How does it keep itself warm? Thick layer of fat, right? That is one. ठीक है, तो बस be aware. आपको अभी भी जिस स्लाइड में जो अभी हो सकता है, many of you don't know krill, पहली बार देख रहे हो, krill कहीं लिख लो. You will see some of these species somewhere else, and many times UPSC has the habit of giving you a sequence or a chain. If you know what is a krill, it becomes easy. If you don't know it, वो मुश्किल हो जाएगा सवाल. This is how it is. Yes or no? Okay. If you follow till here, I think I have two questions for you. Again, a UPSC question. Please see this. Maybe you don't know everything, but at least you can definitely say, please see everybody. Again, for you, this is question number 1. I don't want, if you give the right answer, excellent. But you tell me between which options are you confused? Hmm? A and C. Okay. Other people? बताओ. कोई anybody at the back? Start किससे होना चाहिए? That is a very easy way of thinking. You may not know the exact answer, but you can tell me in which two options are you confused, if that be the case. कोई ऐसा है जिसको चारों ऑप्शन में मुश्किल लग रहा है? सारे मुश्किल लग रहे हैं, ठीक है? ओके. People online, what happened? या फिर my screen is not refreshed? आप ट्राई करोगे? अच्छा, चलो. Somebody has mentioned B. Okay. Only 3 options left. आप ट्राई करो. A and C have already booked. The only option now left is D. कौन बता रहा है D? A और C. अच्छा, ठीक है. देखो, in this question, how many of you are seeing crustaceans for the first time? You can say sir, crust तो सिर्फ डोमिनोज जाके सुनाई देता है. Crustacean क्या है ये? What is crustacean? अच्छा, any example of crustacean that you can tell me? No. Corals are Nidaria. और सोचो, क्रस्टेशियन सुना है कभी? नहीं सुना है तो भी. The objective is not to make you remember what are crustaceans right now. चलो ठीक है. हेरिंग सुना है किसी ने? What can be a herring? Fish. चलो. The question says correct sequence of a food chain. Where would the food chain start? From where? Phytoplankton से? This is almost. So where should it start with? It has to start with diatoms. In how many options do I have diatoms? Only 2 options. So the answer, if you are confused between A and C, you are on the right track. I'm not expecting you to know crustaceans or herrings. अभी मैंने पढ़ाया भी नहीं है. Herrings, of course, in that sense is a fish. Crustaceans में you can think of examples like lobsters, crabs, etc. These are crustaceans. In this question, even if you were able to arrive till here, that's okay. But I'm just telling you the way UPSC is also asking you questions. Right? So in some cases, which is why whatever, because generally speaking, people will not have. आजकल ये भी है, let's say if somebody is watching some of the documentaries, okay, oceans पे, planet पे, I have a recommendation. If you have time, you can spare some time for this. One is Planet Earth. Second is I just checked the name. I think on that the dub is by the former US President Barack Obama. I think that is related to oceans. Very recently, it has got a lot of awards. Even I am yet to see that. Oceans पे कुछ है. I'll just tell you the name. Sometimes what happens, let's say you spend 40-50 minutes on this. The name is Our Oceans. Okay, this is there on Netflix. Okay, Barack Obama has done, and I think he was in news very recently because he has done the narration and some of the awards he had got. Our Oceans. Planet Earth is pretty good. Now, although this will take initially some time, but the good thing is your biomes ka topic, a lot of other topics, सब कुछ इसी से cover हो जाता है. If you see this. And those students who have, let's say, done this hard work, at least 1 or 2 questions का advantage मिलेगा आपको. Fine. And it is always good. ऐसा मतलब don't do this as a burden or a burden. Okay. Yeah, that you can also answer. Although उसके और भी तरीके answer करने के. But if you have an interest, if you want to see this, this will be a very good way for you to explore environment. Okay. This, yeah, our oceans. Because many new questions are getting asked in the sense that you will not even find them in conventional books. But if you have seen them, right, अब they will have proper shots, they will go in the Arctic, they will go in the specific vegetation, वहां पे एकदम आपको live दिखाएंगे या देखेंगे. Nothing can match that, okay, that level of, let's say, work. And this will not also take much time. And this exercise is not very helpful when the exam is on the top of your head. Right now, let's say if you spare some time, you can do that, fine. Okay. So this is one question we saw. Another question which I want you to answer is this, slightly complicated, but you can easily do it. This for ourselves is question number 2. And we will come to this question when we do aquatic ecosystems again, then you will understand. For now, if you have time, you can see the differences between crustaceans and herrings. But later on, this will get very clear when I do aquatic ecosystems with you. A question dekho. This is question number 2. People online can answer this. And write the answer as question 2 या 2 dash करके the answer. Anybody who wants to give the answer? I think this is, we've done it in a simple format, so this you should be aware. You want to try? अच्छा, पीछे? B, up? A, ठीक है. Only 2 options remaining now. आप try करो. B, B. Okay, this is almost a consensus here. अच्छा, why A? फिर से पढ़ो ध्यान से. ठीक है, देखो, the question says which of the following, and UPSC never ask you directly. हमेशा indirect क्या पूछ रहा है? क्या पूछा? Primary producers. What is the alternate name for this? What is the other name for primary producers? Other name. They're exactly asking you, do you remember phytoplanktons or not? So, are copepod phytoplanktons? नहीं, ये क्या है? Zoo. Cyanobacteria? Yes. Diatoms? Yes. Foraminifera? No. These are zooplankton. Now, when you are here right now in the foundation also, and when you see the framework of questions, आप ही सोचो psyche क्या है examiner का? Okay, if you just search phytoplanktons on Wikipedia, you'll find some of these names. And the moment you search zooplanktons, you'll find these names. So the framing of the question is they had given you 4 options. In that 2 are phyto, 2 are zoo. They want you to eliminate. Okay, and even if this question was now this में आपको पता है 2 and 3 answer आ गया. Up the next level of difficulty in the recent times you were seeing in UPSC, the question can be for questions like this, you need to be more precise and more specific with your knowledge. Right? So in certain sections, we'll go the extra mile. We'll see some of the names of species, for example. But in other questions, because not every question is only one. But in other questions, even reasonable approximation will also help you out. So for this, the best guide for you is your previous year questions. Yes or no? That you can also see, right? People who are watching this online also, for PYQs, even I'd taken a session in the March of this year only. I think it's around an 8-hour session of the environment PYQs. If you have time, okay, in between time classes, if you want to see, you can see that. But again, I think in the coming, most probably around maybe January, etc., we'll again have the session, which will also include the paper of 2025. इस वाले में we have covered the last 10 years topic wise questions coverage is there. In case somebody wants to see that, you can also see that. Okay, that can help you. Or if you want to see it after the classes also, that is also okay. ठीक है? That is one. Now, थोड़ा सा आइडिया लग रहा है क्वेश्चंस के बारे में, नेचर एंड रेंज ऑफ डिफिकल्टी. सो इन सम सेक्शंस दे विल आस्क यू स्पेसिफिक क्वेश्चंस, right? So which is why you need to know some of the terms. What is copepods, foraminifera, what is diatoms? And the previous year questions from that sense are very good guiding light for us. Fine. The food chain we understand. In food chain now you also have another topic, that is the food chain in, one is terrestrial food chain, one is aquatic food chain. Another type is grazing food chain, and one is detritus food chain. These food chains are named based on the activity, right? So if the flow of energy is because of the process of grazing, it is named as grazing food chain, right? Right, the activity of grazing. Whereas if the flow of energy is through detritus, now detritus simply means it is the dead remains of either plants or animals. These are of course decomposed. We know examples of decomposers. Batao. Bacteria and virus, yes or no? Chalo, very good. It is not virus. Bacteria and fungus. These are example of decomposers. Fine. So dead animals say be a dead remains say energy if it flows. This is known as detritus food chain. Okay. In that sense, there is an example of wood louse. This is again one of the, एक अभी term मैं आपको और introduce करूंगा. A term is known as detritivore. Okay. Just in maybe 5 minutes, I'll come to what is a detritivore. Let's first see here again grazing food chain and detritus food chain. Okay. Grazing food chain में main चीज है, अच्छा, don't write this. Grazing food chain में main thing is the flow of energies from the process of grazing. Whereas detritus food chain में the flow of energy is because of the process of decomposition of dead matter. It can be plants, it can be animals. Is that clear? So you have a grazing food chain and you have a detritus food chain. पहले तो ये clear होना चाहिए, right? Second thing that you need to know, I want to ask you, grazing food chain, does it dominate in aquatic ecosystems or does it dominate in terrestrial ecosystems? सोचो. And second question will also be this: detritus food chains dominate in aquatic or terrestrial? Hmm? ये हो तो सकता है both, but अभी दोनों में choose करके बताना है which one. Good, good, सही सोचा. और सोचो. See how I remember this, I'll tell you. I remember this by thinking जो सही आंसर लग रहा है वो नहीं है. ठीक. So in grazing food chain, your mind will be tempted to think the answer can be terrestrial. The answer is aquatic. One reason is good. This, in aquatic you have a lot of seagrass. Okay, you have in fact major flow of energy in aquatic ecosystems happens via grazing food chain. But in terrestrial ecosystems, detritus food chain are more dominating. Okay, so यहाँ पे 2 lines you will write. I'll just make you write this down. What we are writing and expressing. One is right. Grazing food chain पे लिखेंगे that in a grazing food chain, the flow of energy starts with the process of grazing by herbivores. Starts with the process of grazing by herbivores. Right? The grazing GFC starts with living autotrophs. Living autotrophs. ठीक है? Second, right, GFC is more abundant in aquatic ecosystems. GFC is more abundant in aquatic ecosystems. Because primary producers, bracket में phytoplanktons, because primary producers, bracket में phytoplanktons, are rapidly consumed by zooplanktons. These are rapidly consumed by zooplanktons. ठीक है? Write the examples of GFC for both. पहले लिखो land, a simple grazing food chain you'll make. You can write grass, grasshopper, frog, snake. Write example of GFC in terrestrial. Grass, dash, grasshopper, dash, frog, dash, snake. Simple grazing food chain है. Grass, grasshopper, frog, snake. This is on land. Second example है aquatic में. Right, phytoplanktons, dash, zooplanktons, small fish, large fish. Right? Then write detritus food chain, DFC. Detritus food chain. Right? It begins with dead organic matter. It begins with dead organic matter. As energy source is broken down by decomposers. It begins with dead organic matter. As energy source is broken down by decomposers. As energy source is broken down by decomposers, right? यहाँ पे you can write example, dead fish. Dead fish is acted by a decomposer, so write bacteria. Dead fish dash bacteria. Bacteria लिखोगे तो नीचे ब्रैकेट में कहीं लिखना this is a decomposer. You've seen bacteria and which is a decomposer? Fungus, yes? So bacteria, dead fish, bacteria. Then crabs and large fish. Crabs, large fish. And write a note. DFC is more abundant. DFC is more abundant in terrestrial systems due to large accumulation of organic matter. It is more abundant in terrestrial systems due to large accumulation of organic matter. Bracket में लिखो fallen leaves, wood, etc. Fallen leaves, wood, etc. Okay. Now there are also a couple of terms because I have mentioned food chain. Please write. एक heading लिखो common terms. Again, we'll see trophic level. We have not written the definition yet. We'll write the common terms in this dash करके food chain. After that, we move to food web. First term, please write is trophic level. उसके बाद basic देखेंगे. First, second, third, fourth level. right? Trophic level is the position. From now we'll write this as TL. It is the position that an organism occupies. It is a position that an organism occupies in the food chain. It occupies in the food chain. It indicates whether an organism is a producer. It indicates whether an organism is a producer or a consumer. Okay, full stop. Then please write down simple definitions. Write producer, put a dash, write first trophic level. The very first trophic level will always be a producer. So give the example plants. Example plants, algae, comma phytoplanktons. Phytoplanktons are a producer in aquatic ecosystem. Producers are your first trophic level. अब लिखो, अब पॉइंट आएगा कंज्यूमर, बट वी आर राइटिंग फर्स्ट इज प्राइमरी कंज्यूमर. राइट, प्राइमरी कंज्यूमर. Now you tell me with whether primary consumer, who are primary consumers? Who eat? Producers. If I say primary consumers are carnivores, true or false? What are carnivores? They eat meat. So these, they have to be herbivores. Yes or no? So लिखो primary consumers, dash लिखो second trophic level. Second trophic level. Put a dash and write. They are herbivores which eat plants. They are herbivores which eat plants. Example लिखो, deer. Example is a deer. About secondary consumer. Secondary consumer is third trophic level. Secondary consumer for us is the third trophic level. You'll write carnivores that eat herbivores. Example में क्या जाए, that carnivores that eat herbivores. You can give the example of the small fish eating zooplankton. The small fish eating zooplankton. These are very basics, but if you have a grasp on them, the topics, other related topics would not be a challenge. Then the last is tertiary consumer. Tertiary consumer is your fourth trophic level. Tertiary consumer is the fourth trophic level. Dash के लिखो predators that eat carnivores, या predators that eat other carnivores. Predators that eat other carnivores. Yesterday class we had seen what is predation. याद आ रहा है? What is the difference between parasitism and predation? The better answer is who is getting benefit. In parasitism, the smaller or the weaker organism is getting benefit. The host, it is dominant, but host is getting harmed. In predation, the dominant organism is getting the benefit because it is ultimately killing it. One thing. Second point of difference was parasitism and predation. Right. Predation, death is certain, whereas in case of parasitism, it is not going to happen. Only in one extreme case, the death will happen. Parasitoids. याद आ रहा है हमें? ठीक है. In this, write the example. Tigers हैं, sharks हैं, etc. These are examples. Tigers, sharks. Okay. So see, these are some of the common terms for food chain that you need to know. So now when you see any of the trophic levels, this will make sense. Now we have a food web. Okay. See what happens in a food chain. Things are present in a linear manner, line में. Food web में क्या होगा? These are complex and interrelated interactions. Yes or no? So these are not in one line only, but they will have multiple. So main thing is, remember, these are more realistic, these are more complex. And this is like how you see in the nature, right? So write food web pe one line. It is a complex network of food web. It is a complex network of interconnected food chains within complex network of interconnected food chains within an ecosystem. Unlike a simple food chain, तो complex एक keyword है and one is interconnected. Underline both of them. It is a complex network of interconnected food chains within an ecosystem. Unlike a simple food chain, right? Full stop, right? A food web shows diverse feeding relationship. A food web shows diverse feeding relationship and energy flow between organisms. Diverse feeding relationship and energy flow between organisms. Now, I want to ask from you, if we want to have a food web, do you want it to be more diverse? Do you want it to be more complex? You want it to be more diverse or very simple? Diverse. You want it to be very interconnected or not? It should be interconnected, yes. So you want both. You want diversity also, and you want complexity also. Let's say, for example, आपने सुना होगा, if somebody has to invest in a portfolio, everybody says make it as diversified as possible. क्यों बोलते हैं? Right? आपने सुना term hedging the risk. Okay, minimize the risk, which means, and it is also said, don't put all eggs in one basket. Right? If anything happens, you will lose everything. That is the issue. So here the main point you have to understand, food web, the more complicated it is, the more diverse it is, the better it is. Okay? So just इसके you can write a diverse food web, a diverse, complex and interconnected food web, a diverse, complex and interconnected food web ensures resilience by providing alternate food sources, and reduces the impact of loss of single species. Okay? That is what you need to know about the food web. Now, हमने ये देखा भी detritus food chain. We've seen food web. We then come to a concept known as pyramids. Ecological pyramids. Because energy flow में हमें क्या देखना है? One is food chain that we've seen. One is food webs that we've seen. Now we see pyramids. And we'll end it with 10% law and ecological productivity. Right? Pyramids देखते हैं. Normally, pyramids look like this. Yes? If you see a pyramid like this, we will call these pyramids are upright. But you'll also see pyramids like this. These pyramids will be inverted, right? So basically you have three types of pyramids. We'll see pyramids of numbers, we'll see pyramids of biomass and pyramids of energy. ठीक है? पहले एक basic सी definition we'll write it. One maybe we can write is this: an ecological pyramid. It is a graphical. अब देखो already we know these things, trophic levels, the arrangement. So it is a graphical representation. It is a graphical representation of the relationship between different organisms. It is the graphical representation of relationship between different organisms in an ecosystem. Right? Second, we'll write it. It is of three types. It is of three types. One is pyramid of numbers, one is pyramid of biomass, one is pyramid of energy. ठीक है? Now write the heading pyramid of numbers. Pyramid of numbers. देखो, we'll see both the examples. See, pyramid of numbers में first understand the pyramid is based on the numbers. For example, you have grasses. हो सकता है these you have 1 lakh in numbers grasses. You have grasshoppers. Let's say you have around thousands of grasshoppers. You have, let's say, hundreds of birds, and you have around 10 hawks. अगर मुझे number arrange करना है, would I make a pyramid like this? It will be tapering upwards because the population is maximum at the base, but it is decreasing. How do I know that? Because we have counted the numbers, for example. The pyramid of numbers will usually be upright. Okay? And one of the very good examples here is this. Let's say this is a grassland ecosystem. Now, the kind of question will be asked to you whether the pyramid is upright or whether the pyramid is inverted. This will be asked. So, normally in pyramid of numbers, if I draw a pyramid and I'm drawing this pyramid counting the number of species in a trophic level, yes or no? So, upright कब होगा? In this case, normally जहां वो grassland ecosystem हो, because the producer will always be dominating, yes or no? Producer ढेर सारे होंगे, small grasses here and there everywhere. So this is a basic example of pyramid of numbers. इसमें just write one line. Pyramid of numbers. Pyramid of numbers represents the number of individual. It represents the number of individual at each trophic level. Number of individuals at each trophic level in a given ecosystem. In a given ecosystem. An example you can write: upright pyramid. Example of an upright pyramid, right? Here the number of organisms decreases. Here the number of organisms decrease as we move upwards. Number of organisms decrease as we move upwards. Number of organisms decrease as we move upwards. Example we'll write is grassland ecosystem. Grassland ecosystem. Very prominent example can be this. Grassland ecosystem. ठीक है? But this is not the only case. Ab now write pyramid of numbers में write inverted. And इसमें भी there are two cases. One, this shape is by the way known as spindle shaped. The best example of this is trees. Now what I can say, this is partly upright, or I can say this is spindle shaped. And the pyramid of numbers can also be properly inverted also in this case also. Okay. अब इसमें why this is happening, I'll tell you. See, if I count, producer had tree, how many trees are there? Let's say there's one tree. Okay. In one tree, it is visited by around, let's say, hundreds of birds. But the carnivore, let's say hawk, eagle, are limited in number. If I draw that, this will become a spindle shaped. So this is partly upright or partly inverted. Another example is, again I take a tree, but here only instead of birds, I'm also counting the parasites. Parasites छोटे होंगे and there will be many in number. So for example, let's say tree is one, herbivores are, let's say, hundreds, okay, more in number. Parasites are छोटे छोटे बहुत ढेर सारे होंगे. Hyper parasites are even smaller. They'll be even more. So this is an inverted pyramid of number. Main thing is, in a pyramid of number, the pyramid is made based on approximate counting of species. Number है यहाँ पे हमारे पास, इसलिए नाम ही है pyramid of numbers. Yes. Now I want to ask you, if I want to make the pyramid of numbers for aquatic ecosystem. Aquatic ecosystems में who would be the producer? Phytoplanktons. Now you tell me whether that will be upright or whether that will be inverted. क्यों? बिल्कुल, they will be huge. Phytoplanktons are very small, microscopic organisms. So they will be very huge, just like this. Exactly यही बनेगा almost. Huge number of phytoplanktons, followed by herbivores, followed by carnivores, followed by top carnivores. Because here I'm counting the number. This is the case of pyramid of numbers. So you have upright also. Example क्या हो गया? Grassland ecosystem. But if I take tree, in tree, if I only talk about, let's say, herbivores, it will be spindle shaped. If I also take into account parasites and hyperparasites, it will be an example of inverted pyramid. Pyramid ulta ho gaya. And why is it inverted? Because less number at the bottom and more number at the top. Simple सा pyramid बनेगा. ठीक है? This is pyramid of numbers. Second one is pyramid of biomass. अब देखो, biomass में what I'm taking the dry weight of the organisms. I'm not counting their number. मैं क्या देख रहा हूं उनका weight. Yes or no? Now you will have another case. This is pyramid of biomass. जैसे कि you have 900 kg of grasses. यहाँ पे we are taking the weight. 100 kgs of mice, 50 kg of snakes, 10 kg of owl. Right? Even if you draw that, you will also get biomass, and this is also upright, and this is also inverted. Okay? So one example is, in a particular ecosystem, terrestrial ecosystem also, क्योंकि grasses ढेर सारी हैं, grasses are heavy also. Okay, overall spread number भी ज़्यादा है, plus their weight overall is also more. If I combine all of that, so this also happens to be a simple case of upright. इसको बोलते हैं upright, and then when it flips, this is inverted. Yes. So here, in the case of pyramid of biomass, because when I'm calculating the weight of the species in each trophic level, हर trophic level पे अगर मैं weight calculate करूंगा, that is based on biomass. If I calculate the number, that is pyramid of numbers. Okay. So here this is the case. In the case of pyramid of biomass, so you can write pyramid of biomass में it represents the total mass. It represents the total mass of living organism. Total mass of living organism at each trophic level. At each trophic level. Full stop, right? Biomass is usually measured in units like. Biomass is usually measured in units like grams per square meter. Grams per square meter. Okay. In case you've drawn the example of an upright pyramid, write example forest ecosystems, the grassland ecosystems. Here the producers dominate both in number also and also in biomass. right? Now in this case you also have an interesting example of inverted pyramids. Any idea which will be inverted? अब देखो, aquatic के केस में phytoplanktons can be much in number, but remember these are microscopic, बहुत small होंगे, बहुत small, very small, so they don't contribute much to the weight. So in biomass this becomes a inverted pyramid. Okay, so you can write here inverted case में it is found in aquatic ecosystems. Now if you want to know the main reason पहले तो क्या है? Phytoplanktons are more in number, but the biomass is less. And one reason why biomass is less is the moment they are easily or very rapidly getting consumed by zooplanktons. So they don't let them accumulate. They keep on eating. So constant flow of energy is there. So biomass wise they are less. Main cheez hai, zooplanktons keep on consuming them very fast, very rapidly. Right? This is the case. Now let's recall, and after that we go to pyramid of energy then. अभी तक दो देखिए pyramids. One is pyramid of numbers. Pyramid of numbers is upright in which case? Grassland भी होगा, forest भी होगा in most cases. Is it spindle shaped? Can it be spindle shaped? Can it be inverted? Yes. Okay. In the case specifically, let's say of which, let's say tree, right? Then it is not going to follow the exact same. Number one. Second, you have a pyramid of biomass. Can pyramid of biomass be inverted? Which case? Aquatic ecosystems. Can it be upright? Yes. Which case? Forest hai, grasslands hai, yes. Third is the pyramid of energy. Okay. अब यहां पे producers, let's say whatever energy they produce, okay, this should be 1000. हाँ, primary consumer, secondary consumer, tertiary, यही देखा था हमने, right? And we are arranging things as per the level of energy. Very simple. Okay. Now maximum energy will be at the producers. This is more or less certain. And in each level, how much energy is transferred? 10%. सिर्फ 10% transfer होती है. 90% energy gets consumed in metabolism and respiration. 90% gets consumed. 90. Right? So you have producers, primary consumer, secondary and tertiary consumer. Right? Few things to remember. Flow of energy, a direction, is it bidirectional or unidirectional? Uni. From plants, it will go to primary, from primary to secondary, secondary to tertiary. Yes or no? So flow of this is one thing. Second thing, please remember, in pyramid of numbers, in pyramid of biomass, you had the example of inverted pyramids. In pyramid of energy, the pyramid can only be upright. It cannot be inverted. It can never be inverted. The reason is energy सबसे, and the reason for that is 10% law. ज्यादा एनर्जी है, वहां से कम, वहां से कम, वहां से कम, उल्टा नहीं हो सकता. If that becomes ulta, that becomes inverted, it will be against the laws of thermodynamics. What does thermodynamics say? कि भाई there is always going to be some heat loss, there will be some entropy. Okay, it cannot be that you have 10 kilojoules of energy and वहां से आपकी 100 बनेगी और वहां से आपकी 1000 बनेगी. The opposite is true, that from 1000 you can make 100, from 100 you can make 10, but the opposite is not true. Yes or no? So pyramid of energy, first thing is it is unidirectional. Second thing is it is always upright. Yeah, it is always inverted. Always upright. Simple logic क्या है? Producers dominate करेंगे. They are the ones who produce energy, and 90% energy is lost in every trophic level. Only 10% energy is transmitted from one trophic level to the other. Are we clear on this? नहीं नहीं नहीं, एनर्जी का सिंपल मतलब यहाँ पे कैलोरीज है. ठीक है, न्यूट्रिएंट्स विल बी अ मोर स्पेसिफिक पार्ट ऑफ इट, बट मेन इज एनर्जी. ओके, एनर्जी जैसे फॉर एग्जांपल इन द केस ऑफ एन ऑटोमोबाइल विल से इन टर्म्स ऑफ इट्स हॉर्स पावर. ठीक है, राइट, किसी फ्यूल के केस में उसकी कैलोरीफिक वैल्यू हो गई, तो यहाँ पे भी दैट इज द अमाउंट ऑफ एनर्जी इन अ प्रोसेस, हाउ मच इट इज क्रिएटिंग। ओके, हाँ, जूल्स, जूल्स, किलो कैलोरी है जूल्स में। इसको देखो ध्यान से, 100% से 10%, क्यों 10% लॉ, 10% से 1%, अगेन 10% लॉ, 1% से 0.1%, अगेन 10% लॉ। ओके, नाउ प्लीज रिमेंबर, it is unidirectional, second it is always upright, third 1/10, which means each level you will have only 10% energy getting transmitted. It reflects the laws of thermodynamics, right? That from one level to the other there will be a loss of energy, and that loss is happening because of two things. One is metabolism and second is respiration. 90% energy is getting consumed in that. Okay, that has to be understood. Okay, so for pyramids of energy, I think if you've made this diagram, एक लिख लो, एक अलग से इसमें देखो, pyramid of energy में just a couple of lines, please write. It represents the flow of energy. It represents the flow of energy at each trophic level. It represents the flow of energy at each trophic level. Full stop, right? Energy pyramids are always upright. Energy pyramids are always upright because energy decreases as it moves up the trophic level. Energy decreases as it moves up the trophic level due to the 10% law. Due to the 10% law. Now write a mini heading, 10% law. Right? It was given by Lindman, Lindmann. It was given by Lindman in 1942. Just a factual point. Most probably this will not be asked, but the concept you should remember. So, right, only 10% of the energy, only 10% of the energy is transferred from one trophic level to the other. And I'm emphasizing this again and again. Don't think 10% is lost. Loss kitna hoga? 90%. So, right, only 10% of the energy is passed from one trophic level to the other. Full stop, right? The remaining 90%, is used for respiration or metabolism or is lost as heat. Respiration, metabolism or is lost as heat. अब नोट करके लिखोगे, write a note, write the 10% law and the pyramid of energy limits the number of trophic levels in an ecosystem. It limits the levels of trophic level. It limits the number of trophic levels in an ecosystem because energy becomes insufficient at higher levels. It limits the number of trophic levels in an ecosystem. वरना आप ये सोच सकते हो कि सर why stop at 4 or 5 trophic levels? Why not have infinite trophic levels? The reason is energy is also getting lost. 90% energy हर level पे loss हो रही है. So beyond 4th or 5th trophic level आपके पास energy है ही नहीं. And that is how the entire life is going to be propagated, right? So what have we written? Because it limits the number of trophic levels in an ecosystem because energy becomes insufficient at higher trophic levels. energy becomes insufficient for higher trophic levels. And then this is basically, so this is nature's way of ensuring continuity. Otherwise, organism चीजें कभी रुकती नहीं, right? Which is why you have only limited number of predators. One reason is उनके लिए खाने के लिए भी इतना चीजें नहीं है. तो जितनी चीजें हैं, these are enough to sustain the life and sustain the biodiversity. Yes or no? Okay, now if we see our mind map of this topic, हमने क्या क्या कर लिया इसमें देखो. Food chain we have done, food web we have done, pyramids we have done, 10% law देखा. अब आते हैं limitations पे, right? The heading limitations of pyramids, which simply means even pyramids are not perfect. They also have issues. सब पे every, yes. नहीं, हमारे पे एक और इशू है. वी ऑल्सो नो constantly we can make food also, okay, but everything, for example, even in our case, most of the energy will be used by the cells, okay, in metabolism and respiration, right? So इसलिए हमारे भी ऊपर मेन चीज है, because we are also part of the nature only, and this basically tells you most of the energy gets consumed by cell will take a lot of energy. We cannot create infinite energy, that is the main point. हम भी थकेंगे, ठीक है. दैट इज वाई यू ऑल्सो टू ईट आफ्टर पॉइंट ऑफ टाइम. यू कैनॉट, ये ऐसे नहीं होगा सुबह एक मील खाई, अगली मील 4-5 महीने बाद खा रहे हो आप. द कांस्टेंट एनर्जी नहीं होगी. दैट फूड इज गेटिंग ब्रोकन डाउन, इट इज गेटिंग यूज. तो बॉडी कांस्टेंट एनर्जी डिमांड करती है आपसे. अब ऐसे सोचो, विच इज ऑल्सो वाई फॉर एग्जाम्पल अ लायन also has to continuously hunt, and that is how they maintain a balance in the number of population of deers and then the grasses. What if the lion says ki chalo I'll go for a vrat, okay, a fast? What will happen? The deers will increase, and deers will increase. What will happen? We have seen a term, trophic cascade. All the grasses will be eaten up. So this is the way of managing it. But इसमें problem कहाँ आएगी? Problem is when there is unsustainable consumption. For example, if people are hunting all the lions and tigers, humans are doing it. If people are over consuming, जैसे भी क्या होगा? In case of poultry etc., over consumption होगा. That can alter the balance. But from an energy perspective, वो हमेशा common रहेगा सबके लिए. Because sun is there, photosynthesis, nothing of that sort is going to change. Okay. We are seeing the limitations of pyramids. Okay. Only the keywords you'll write. सबसे पहली चीज है, एक one thing, it does not take into account same species belonging to 2 or more trophic levels. Right? Sometimes a sparrow, okay, or sometimes a gilheri. What is the name of gilheri? Squirrel. So squirrel or sparrow, they can sometimes be primary consumer, they can also be secondary consumer. But in the pyramid, you are giving them only one trophic level. So it means in trophic level, आपने मान लिया जो भी species एक level पे है, it cannot go to any other level. This is a limitation of a pyramid, because some species can be at both levels. So it does not account for it. So first limitation of a pyramid is it does not take into account the same species belonging to 2 or more trophic levels. Do we agree on this? Give the example of sparrow and also squirrel. Sparrow as well as squirrel, they can be at both levels, but it is only present in one. First issue. Second, yahan pe bhi, do I not assume a simple food chain? This is eaten by this, this is eaten by this, this is eaten by this. Okay, it assumes a simple food chain, but in reality nature things are very complicated. Okay, it does not accommodate a food web. Food web काफी complicated हो जाएगा. It only assumes a simple food chain. It does not accommodate a food web. Then last one, you can also write saprophytes लिख सकते हो, नहीं तो you can also mention decomposers. Now there is never a mention that even in the top they will die, decompose होंगे, and फिर the energy is going to come back. Yes or no? Detritus part. So saprophytes, or you can write decomposers, are not given any place in the pyramids, but they play a very vital role. Tomorrow, in fact, we'll also have a short discussion, 10-15 minutes on saprophytes also, decomposers also. But main thing is they are not included in this. मतलब कल मतलब फिर वही नेक्स्ट। ओके so limitations now you know. And the last heading was very small heading for today is ecological productivity. Ecological productivity. देखो productivity we had just discussed, yes or no? देखो if I just draw it and you should write this with me, जैसे what is productivity is simply production divided by या तो time होगा, in ecological case it can be also time, it can also be area. Production divided by time or area, yes or no? Now when I say productivity in ecological sense, this can be primary also, which means I'm talking about producers. What will be production for producers? क्या होगा? Energy, which means basically the carbohydrates etc. during the process of photosynthesis, right? So for example, I'll take two cases. One is a open ocean. One is an ecotone, and let's say the example of wetland. Now, everything here is about numerator and denominator. Fraction पता है हमें ऊपर क्या होता है? Numerator, नीचे क्या होगा? Denominator. देखो, open ocean has a huge area, yes or no? Open ocean will also have phytoplanktons. They will produce food. But अगर मैं इसका fraction बनाऊंगा, they cover a huge area, the phytoplanktons. Okay, the area is big. The production may be big, but because the area is very big, the fraction may be less. Yes or no? Open ocean में, which is why the productivity of oceans is lesser. क्यों? क्योंकि denominator is huge. But हम बात करते हैं wetlands or mangroves. Why are mangroves very productive? One reason is these are ecotones. What are ecotones? Transitional zones between two ecosystems. First of all, area is limited, very limited area. And second is these are highly productive. क्यों? यहाँ पे phytoplanktons हैं, ढेर सारे birds आ रहे हैं, visit कर रहे हैं. So you have whatever sunlight is there, you are having good production divided by a small area. Fraction बड़ा हो गया. Productivity बड़ी होगी या कम होगी? ज़्यादा होगी. So if I say productivity of wetlands is greater than oceans, true. But I'm not saying production is greater. I'm saying productivity. The reason is this simple formula. So again, recapping, what is productivity? Productivity is production divided by time or an area. Okay. In the ecological sense, what is productivity? It is simply the rate of biomass production during the process of photosynthesis. And when I emphasize rate of biomass production during photosynthesis, I'm talking about primary ecological productivity, which means there can also be secondary ecological productivity. What would that be? The rate of biomass production that is by primary consumer. Yes or no? So deers or rabbits were eating up the plants that are available. That is an example of secondary. So secondary ecological productivity will be about not primary producers, but this will be about primary consumers. Are we clear on this? Now, one more concept is there linked to this. चलो यू टेल मी व्हाट इज ग्रॉस सैलरी एंड नेट सैलरी, सुना हमने ये? ठीक है, चलो ग्रॉस सैलरी इज लाइक अ वादा, सपना. What is net salary? Hakikat. Can I say this? Gross is everything that is promised. Okay, so gross, let's say somebody's gross salary is, let's say, 10,000. Net salary is the deductions that will happen, for example. Okay, whatever things are removed. So let's say this is 9,000. Same concept is also used in productivity. So you have gross, let's say, ecological productivity. That simply means total productivity. But there will be net. Net is defined as gross ecological productivity minus respiration. Simple. यहाँ पे मैं taxes हटा देता हूँ. This is just for your reference. यहाँ पे you have respiration. That's it. So basically you will remember that GEP, gross economic, sorry, ecological productivity, it will be greater than net. True or false? Yes. Because there will always be respiration loss. This is the thing to understand. So बहुत बार people think that why estuaries, why mangroves, why wetlands have a higher productivity as compared to open oceans. We are not saying that they have more production, but we are saying they have more productivity, and it is all there in the numerator versus denominator, as simple as that. Ecotones in general will have smaller areas to talk about. Yes, and there is gross and there is net. So this is something that we can also have a look at. So now, just to summarize this, 3 or 4 definitions we'll write whatever I've written here. लिखो rate of biomass production. The heading is ecological productivity, right? Rate of biomass production. Rate of biomass production is called as ecological productivity. Rate of biomass production is known as ecological productivity. Right? Primary ecological productivity. Primary ecological productivity is defined as the amount of biomass slash organic matter, produced per unit area over a time by plants during photosynthesis. This is making it very obvious. Even if we did not write photosynthesis, it would have been in photosynthesis only. Amount of biomass slash organic matter produced per unit area over a time period by plants during photosynthesis. Right? Then write gross GPP, gross primary productivity. Just dash करके लिखो. This is the total rate of production of organic matter. Total rate of production of organic matter. Then write NPP, net primary productivity. NPP is equal to GPP minus R. NPP is equal to GPP minus R. R here is respiration losses. R here is the respiration losses. Right? And last definition is secondary productivity. Secondary productivity. Right? It is defined as the rate of formation of new organic matter by, and write in caps lock, consumers. सेकेंडरी में सीधे कंज्यूमर्स, प्राइमरी में कौन होगा? प्रोड्यूसर्स. तो प्राइमरी में इट इज बाय प्लांट्स, सेकेंडरी में इट इज बाय कंज्यूमर्स. Okay, and I'll end this with a question for you, right? Why estuaries, comma mangroves, comma swamps have higher ecological productivity as compared to open oceans? Even this we have discussed. Have higher ecological productivity as compared to open oceans, right? So in terms of functions of ecosystem, one we have done is ecological succession in good detail. Second we have done is energy flow. Tomorrow we start with nutrient cycling, and then we'll also do homeostasis. So tomorrow, by tomorrow, of course, I mean in the next class. The next class will now be on Friday. Okay, so we will meet then. Again, if you have any other doubts, you can let me know. Okay, or you can just drop a text or a message. People online as well. Okay. Okay. If you want to overall have a discussion, you can just drop me a text, any other dimension or debate about it. But you should see this, of course, in the broader context. Okay. Okay.